Hello everyone, this is Harper Carroll from Harper Carroll AI. Today we're going to go through a very simple coding tutorial to get you started with coding with AI models. So we will use code to download a model and to run it. We will use a coding interface, and we'll talk about Hugging Face, which is a company and website that is a hub for basically all things AI models. So we'll have data there, we'll have the models that we can download, and the code that we can use to work with those models. So I'm excited to have you here. I made a video on Instagram asking you to comment code if you were interested in a coding tutorial, and I got hundreds of comments. So hopefully this is helpful to you, and I look forward to working through it together. Make sure you take notes of your questions, and if you have any outstanding questions at the end, please be sure to comment and let me know how this went for you. So let's work through it. Okay, so you're going to want to start at python.org/downloads and download Python if you don't already have it. And then once that is complete, then you're going to want to open a terminal I like to use iTerm2, but if you don't have that, then you don't need to use it. But I have a pretty one, but it's basically just this, but made pretty. So we can tell that I have Python by, writing Python 3. Oops. Great. So Python 3, I have Python 3.9. So actually, I think I want to update my Python. So yeah, let's just do this here. And I will look at my downloads. I have a special browser called Arc. Okay, so now let's see. Let's open a new shell. Great, okay, so we just had to open a new window, and now it's been updated to 3.12. Okay, so now I want to open an environment, a virtual environment. So this is a place where I will be developing in Python. As you work with code, there are things called libraries, which are basically packages that you can install to make your coding easier. So they take complex code and transform it into one-line function calls that you can call to do all of this code. And so these libraries make coding easier. You don't have to do all the things from scratch. You get to build on top of other people's code. Sometimes there are issues with installing dependencies and, some versions of libraries work with other versions of libraries, and it just becomes a big mess. And so one thing that makes that easier is to work with Python environments. So we're going to set up a Python environment by saying, so I put this together for us to use to make it just a little bit easier. So what we would want to say is you want to make sure that you are in the proper directory where you want to have your project. So I'm going to say cd change directory into desktop. And then I'm going to just make a environment, or I'll make a file. So I'll make dir, make directory, and then we'll say transformers 101. Okay, great. So you can see I just made a file, a directory. Go into that directory, great. And we'll say Python 3 oops. I want to call it, I did Control-C to cancel that. MyEnv. So see, that's running, and it seems to have just done it. So now we want to turn it on. And source, you could also just copy and paste this, but I'll type it out to work with you guys. So now you can see I'm in the environment. And let's say which Python. Let's make sure Python is installed here. Let's say Python version. Let's see. Great, so it has 3.12. So now we want to install, so this is for Modal, which I'm not sure we're even going to use, but let's just get it anyway. Modal helps us use GPUs. So we might need a GPU to work with the model, but let's see. So let's just install pip anyway, because we'll find it useful. So this is grabbing this file, which is the pip download file. And now we're going to run it by typing python get pip. Great. And now that we have pip, see, we can say pip install Modal. Oh, and then to set up Modal, this is the command we need to run, is Python m modal setup. So we'll just let this run. Oh, so it's opening our Modal, and you'll have to make an account here, but I've already made one. So I have an API token, it's gonna redirect me back, and looks like it was successful. Web authentication finished successfully. Great. All right, so now let's go to Hugging Face. Hugging Face, I love Hugging Face. It's the best. So Hugging Face is a company where they have data sets, they have models, so you can, easily train models, fine-tune models with these data sets. Let's just take a look. Oh, these are my own things I'm following. Let's look at the global data set. So you can group them by this type: computer vision data sets, natural language processing data sets. Oh my goodness, it's like a candy store in here. So there's all different types. Let's look at like an image classification data set. How cool. So it's a data set with labels. Remember from the 10 days of AI basics, we talk about how we have the example and then we have the label, or the sample and label. So here we have an image of a woman and she's sitting. So it's just a classification problem. We can see that these are very simple descriptions. I wonder how many classes. There are 15 classes. So rather than describing, you're actually grouping it into one of these 15 categories. And so the 15 categories, I wonder if we can tell what they are. Yes, all of these. So we just saw a sitting example. So these are the 15 categories, and what this data set does is looks at an image and classifies it into one of those 15 categories. Super cool. And so there are lots of data sets like this. Let's look at the models available. Also, I'm so close. Hello. I don't think it's even focusing. I'm having an issue with my Opal where it doesn't focus, but I emailed them, so hopefully they respond. Okay, so look at all these models. You might recognize them: Meta Llama 3, 8B, which means that it has 8 billion parameters, which refers to the size of the model, which is when you are training it, how many numbers do you need to alter? And 8 billion is a relatively small model for the ones that exist these days. So see, here's NVIDIA Nematron, which we talked about in the AI news last week. That's 340 billion parameters. Here's another one, the reward version of that model, or of that family of models. So yeah, which should we work with today? Let's try this Quen model. So look, they have this code already for you, which is super cool. Also, I want you to download VS Code. So go here, I have it already, but download the version that works for you, whatever machine you have, and make sure you have that installed on your computer. Then we're going to open VS Code, Visual Studio Code. Let's open a new project, open, and let's open the directory that we did before, Transformers 101, where we have this virtual environment. So if you do Command-Shift-P, then you can say create terminal, and see we have a shell here. So remember we had the iTerm over here, this terminal. I was using iTerm as my version. So now this opens up another one here. And so we can say, remember what we did to activate the, so here, if I write pip, we don't have it, but if we activate the virtual environment, then we do have it. So let's find that code again. It was this. There we go. Now if I say pip, it's installed, see? Okay, so we're in the virtual environment and we have this sample code. So let's just click here to copy it. And what this does is helps you load the tokenizer in the model. So the tokenizer is what will transform your text into text that is readable by the model. So let's make a new file in here. Let's make it a Python file. Let's paste, and then we can save and just say, make sure we're in the right directory, and we can say, oh, let's put it in my env. We can say, remember this was the mistake file. I should delete that one, but we'll call it Quen. Oh, we also want it to be quen.py. So let's just rename that here. Great. So now, actually, let's just go through this line by line. So device equals CUDA. So this is assuming we have a GPU. So maybe we actually do that. Let's go to Modal. So we installed Modal, remember, and so we're going to need to get a GPU. Actually, I wonder if we can try it without a GPU for today. So in which case we would want to say device equals CPU. So we're putting it on the CPU, which is this machine here, instead of a CUDA, which would imply that we have a GPU somewhere. And auto tokenizer, we're going to pass in this prompt. This is where we could change something. This is just the default, what they give us. And then this is the role of the system. So we're telling it that it's a helpful assistant. You could elaborate. You are an expert on coding, or you are a flight attendant who has been traveling the world for, this is where you define who the chatbot is. And then the user, which is you can pass in this prompt, which refers to, this is a variable, which refers to how it's defined here. So on the left, we have the variable, and on the right, we have in quotes that's saying we're defining it as a string, and a string is text. It's processed as text. So let's say text equals tokenizer. So we've defined this tokenizer. Oh, yeah. So here we have the model. This is transformers. So Hugging Face has a library called the transformers library. And remember, as we said before, libraries are packages that have predefined functions that encompass complicated code to make it easier for the coder, developer, i.e. you, to code. It takes away a lot of the nitty-gritty code and abstracts, as they say, on top of it. So we just have to say, we import these two libraries from transformers, we import these two modules, auto modal for causal LM, so it's detecting the model automatically for a causal language model, and auto tokenizer, so it's just kind of the default tokenizer. And a tokenizer, as I said, is what transforms your text into numbers, into a format that is readable by the model. And each model has its own tokenizer that it was trained on, and you need to make sure that you use the same tokenizer that it was trained on as you use when you are passing in new data into the model, because that's the kind of code that it learned how to speak on. And so you have to use it. It's the same kind of language that it learned before, so you need to speak the same language again in terms of the tokenizer. So here we load the model. We can say it's automatic data type, automatic device, although we set that here, device map. We just say auto. It should be able to tell that it should go on the CPU because it'll see that we don't have a GPU. So device means what kind of machine should you map the model onto. And here we're going to say auto because it'll know that we don't have a CPU. And this is the data type for Torch. And this is just going to be automatically what comes with the model. And then we actually define these. Now we're going to say tokenizer.apply chat template. So we're going to take this tokenizer and we're going to call this function that the tokenizer has. This is a tokenizer function. And we're going to just apply this info to the model. So the tokenizer, again, is taking the tokenizer that is this model. So they speak the same language. Again, we're taking it from the pre-trained model. We want to speak the same language, have the same code that it was trained on. And then we're going to add this new template. So this is, I think, a template with the role and the system and the role of the user. This is a chat template, and this applies it to the tokenizer. And so these are the inputs to the model. We're going to pass in, this is just how it works. You do tokenizer and then the text, which is this here. Return tensors. PT means returns them as PyTorch tensors. So tensors are like a fancy name for arrays in the context of machine learning. So those are the things that we do, arrays and matrices, and we do processes on those, and those are what they're multiplied, and they're the arrays and matrices that we're working with. They're called tensors. And so you might have heard of TensorFlow, which is just working with tensors. It's a library for working with tensors, so it makes it easy to use them. So we have model input. So what this does is it tokenizes this text, this part, which has everything here. It has the prompt, it has the helpful assistant thing. It tokenizes that, meaning it transforms it into the code that the model can understand using that language we talked about with the tokenizer. It returns tensors, which is how the model can speak. So tensors are what I said, and then it puts it on the CPU or the GPU or whatever you're using. Then we want to generate IDs. So now that we have this model input, we want to get the IDs from that, which means just like the token IDs. So it's the numerical representation of this input of the prompt. So now with generated IDs, we are passing in the input in a language the model can understand. We are telling it the maximum number of output for the model to create. So that's like the max length of the output, number of tokens, and then we're telling it to do its magic to generate. And so then you're calling this function generate. And then what this does, this is actually a great example of how we can use Claude to help us code. So let's open Claude. So Claude just came out with a new model called Claude 3.5 Sonnet, which is fantastic, and it's great at coding. And so if you want it to generate code for you, you can just ask it to. So this is a really, really helpful tool for people who are new to coding and seasoned coders alike. So let's just say, can you please explain, can you please explain what the following code does in the context of machine learning models generating output text? And we can just say, what I like to do to show that it's code is to put it in those, because then it'll actually put it there. Look how great this is. Okay. It's using list comprehension to create a new list called generated IDs. It's iterating over two lists simultaneously using the zip model inputs and generated IDs. So it's saying these two, for each pair of input IDs and the output IDs, it's slicing the output IDs starting from the length of input IDs to the end. Okay, so it's putting these two lists together, and then it's saying for each element-wise thing as you're going down. The purpose of this operation is to remove the input tokens from the output, keeping only the new generated tokens. I see, and this is because the output sequence often includes the input sequence followed by the newly generated text. So this is just like a function of how this model works. It returns both the input and the output, and we just want to parse out the output IDs. And so then we're going to decode it. We're going to put it back to English because it outputted it in the tokenizer language, so in the code that the model understands it in, so a series of numbers. So we need to decode. We need to bring it back to English. And then get the first element. This is what this 0 does, is it gets the first element of this list that's returned. And a list looks something like this. So a list is something like this. See, it's just, you can take 0, which is the first element. You can take the -1 as the last, or you could take 1, 2, but 0 in coding, 0 is 1 is the first element. Okay, so now let's run this, but we'll see, we'll get stopped, but let's just try to run it anyway. So ls shows us where we are, what folders are in our current directory. We want to change the directory into, should I ignore this? Oh, okay, we want to activate, oh, it's already activated, so we don't need to do anything. Now let's say Python Quinn, so this is going to run. And it says there's no such file or directory. Did we save it? It's in my env. Maybe we don't want it in there. So let's move this up. All right, let's try it again. Ah, good. Okay, so we don't want it in this directory. We want it just in the Transformers 101 directory. So if we say ls, we see it here now, quen.py. And we can remove that other, oh, it's a directory. The -rf is to remove a directory. Be very careful with this command. You can like wipe your entire computer. But this is removing the directory venv. But if you said rmrf like desktop or rmrf, the name of your user like Harper Carroll, from where it's actually located in the directory above it, you could, or with a correct path to it, which is like a correct location, full code location of where it is, you would be in trouble. Okay. So now we can ls again. We'll see that the venv, which was the error one, is no longer there. And back to where we were, let's just clear it. We'll say python quen.py. So we have this error, no module named transformer. So we need to import transformer. So we could say pip install. So remember we downloaded pip, and now we can use pip to download transformers. And so when you see that command, like no module named X, usually you can just say pip install X. So we'll just wait for this to complete. Great, so now let's try it again. And look, it's running. So it's slow. Oh, this is hard to, okay, so what's the error here? Auto model for causal LM requires the PyTorch library, but is not found. Ah, so now it's time to install PyTorch. So if we say command and then click, we can click on this link and open it. We're gonna have to install PyTorch. So let's put in our specs. So we want the stable build, which is like, we don't want the nightly build. We want the one that we know is good. Mac, we want to use pip. We want Python, and we don't want any of these. We just want the default. So now we can copy this command, go back to VS Code, paste it here, and run it. You might, if you don't have pip3, it should automatically work. Pip and pip3 should work if you just installed pip, but if it doesn't, just remove the 3. So now we're downloading PyTorch. So remember we talked about TensorFlow and how that's a library that helps you work with tensors. So is PyTorch. PyTorch is the meta version of the library, and TensorFlow is the Google version of the library. But it seems that PyTorch seems to be more popular these days. So congrats, Meta, for winning that race so far. They're in the lead right now. But Hugging Face is built on top of PyTorch. It clearly is because you need PyTorch to work with this, but I don't know if they have a TensorFlow version yet. I haven't looked into that. But we know that it uses PyTorch because in order to run the Transformers library, it's telling us we need PyTorch. So this is how dependencies work, where this library relies on this library, which relies on this library. And this is kind of how coding is. Like, people just stack code on top of each other. And it, again, can be a struggle if you have a lot of different libraries and different versions because people are constantly updating their code. But having a virtual environment can help with this. All right, so now let's try running it again. We'll say clear just to have a fresh page. And what I'm doing, I'm using the up arrow on my keyboard to get the most recent queries. And then enter when I'm ready. Oh, it's working. This is gonna be slow because it's on my local computer. Ah, okay, so now we need accelerate. And what you can do is actually make a note of this. So while this is running, I'm gonna say new file, and I'm gonna call it, it's not a, actually, yeah, let's say new file, text file. And let's just put, you know, what were the commands that we had here? We wanted to install accelerate. We wanted to install transformers. Actually, let's do it in the right order, transformers. And then we wanted PyTorch. So we'll say all of these guys, then accelerate. And then you can save this as something called requirements.txt. and then I'll show you how we can use that. So it works, clear, and now let's try running it again. Okay, so we're getting this error, and I think it has to do with the float size. So remember when we set the float size to be, where did we say that? We said like something auto, torch dtype equals auto. Let's see how to resolve this. So one thing we can do is we can copy the whole trace back. Let's open a new chat in Claude. We'll say, I am trying to run a large language model from hugging face and getting the following error. New line, dash, 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 new line. And let's send it. Let's see what it tells us to do. So yeah, I don't want to have to update my Mac. So let's see if there's another solution. We can try loading it with a different precision. So let's try float 32. It's going to be bigger. It will use more memory. I actually think, does an M1 have... Oh, it has a GPU. So let's actually try that instead. Let's say auto. I think it should use, or no, sorry, CUDA. So let's go back. And then if that doesn't work, we can change this torch dtype from 16 to what they said, torch equals 32. So this is, these two slashes are a comment, so it's not actually affecting the code that is running. And let's just, or maybe, oh yeah, two slashes is a different language. All right, so let's run it again. Okay, so it's still not working. So let's try this. All right, see if this works. Oh, and we're gonna have to install Torch. Oh no, we have Torch. It's not defined. We'll say import Torch here. So now it's defined. So now I'm getting this issue, Torch is not compiled with CUDA enabled. So where do we say device on here? To device. And the device we've left it as CUDA. So let's ask. We might have to provide more context, but let's try here. Oh, let's try this. I want to see if this returns true. So one way we can just run a single line is we can open Python, and then we can say, oops, we might have to import Torch, and then torch dot run this. True. Okay, great. So we want MPS, which I guess is, we'll add this code instead. So this is how we're going to define device. Instead of directly setting it, we're going to make an if-else statement. So if this is true, if MPS is available, we're going to set the torch device to MPS. Otherwise, we'll set it to CPU. So I think MPS, right. On Macs, you should be using the MPS instead of CUDA because CUDA is for NVIDIA GPUs, and we don't have NVIDIA GPUs. This is a Mac GPU. So let's quit. Let's clear, and then let's run this again. Okay, another error. Let's see, what does it say? Now I'm getting the error. So we have to create an attention mask. So this is with transformers, it shows what parts of the input to kind of pay attention to, and that's a very simplified term. We'll do a video on transformers and what attention masks are, but we want to just make an attention mask ourselves. So basically it's just looking at all of the inputs. Oh, and what we can say, this is a good example. We can say, please edit the following code. Following code to add an attention mask. And then paste the whole thing. So we're seeing here, it's added the attention mask. Let's try it again. So we can copy it, then we can select all, delete, save. And what does it say? So these are the changes. Let's try it again. So, okay, it looks like it's running. So it's gotten here, it's waiting, it's hanging, see? So the process is still loading because it hasn't gone back to like this. This would mean that the process has completed if that was the most recent line. It's taking a while, so I'm just gonna hang out, but I'm gonna look up how I can integrate with Claude. Please write code for me to use a Modal Labs GPU with my code. Yay, it knows Modal. Wow. Wow, okay, that's cool. Let's copy this. So we installed Modal already. We said Modal token new. I think we did that, but let's just do that if we haven't yet. You know what, this is taking forever, but let's actually just open a new process. So see this plus button, we'll say Modal, and we're still in the same directory, Transformers 101. Modal token new. We define a stub, organizing Cloud functions. We download the model, create a model image that includes the necessary dependencies, and runs the download model function. All right, so let's see. It specifies the uses of an A10 GPU. So let's open a new Quen file. So let's just say new file, Quen Modal. Save it. And we can just input the code that, Claude gave us. So see, this looks very similar to our code from before, but we've defined a bunch of the code as a function that is then called here. So this code returns a model and a tokenizer. So once we call this function, we'll have a model and a tokenizer. Then we do the message, everything here. Then remember, this code is the same as before. And then this returns the response. So this function, generate text, just puts all of this work into this function. And so that's kind of how libraries work, is that it's put all the hard stuff into this one function. And so then we're just running response equals generate text. And the dot remote, I think, is the modal thing where we are actually running it on an A10 GPU. So let's see, where do we define it as an A10 GPU? Here we go, stub function image. Oh my gosh, so let's try this. We can say Python Quen Modal. Oops, I spelled that wrong. Quen. Oh, first we want to save it. Now we want to run it again. There's a little dot here, and that shows that it wasn't saved. So look, it's doing all this modal logic. See how the other one's doing. Still hanging. Should we just end this? Because it'll help the utilization of our computer. So let's do Control-C, canceled it. Great, now this is our main process here. So now that we're not running that, we have more compute on my local computer, on my laptop, to be able to turn on the camera again. Okay, so we're getting this issue, accelerate. That's strange. Seems like we already have accelerate. Let's say which. We have it. I am running following code and getting the error. Oops, typo, but it should understand. Gotcha, we have to make sure it's installed in the Modal environment. So where does he add it here? Pip installed for Transformers Accelerate, cool. So this is installing it on the Modal GPU. All right. Let's see. So we want to replace this line, adds accelerate. Okay, and then we can delete this comment, save it again, clear, and then run it again. Just quick thing to note, as this is running, I'm getting this stub has been deprecated in favor of app. It would make sense that Claude has some old data. We can ask it when it's, I think it was February of this year of 2024, April. Okay, so it's possible that it's older. You can just replace it with app, but it should be fine. Just wanted to point that out. You can read these little messages here. We see that it's hanging here. I keep pressing enter, which is why it just redoes this, but we're hanging at this code. So I copied it and I asked Claude, I said, my terminal output is hanging at this in the same chat as where it created the code for me. And so it's able to tell me it's just because it's downloading the model. It's big, so it takes a while. And it takes a while for Modal to set up the environment. So remember, we're checking out their GPU, so it's going to take some time. But the next time we use this GPU, it should be faster, apparently. Suggestions are to be patient. Oh, we can check Modal status page. Oh, and you can do logging. That's nice. So let's just add that for next time we run it. We can say that's redundant. So next time we run it, it'll enable debugging. It should output it here. Let's check. I wonder if there's anything on my Modal account that I can see. And if I go to logs, I can see that it's initializing. So it says it's currently running. Oh, and we can see the logs here. So it's running the function download model. So here we go. We just got to keep waiting. But that's cool. So you can read the logs here on Modal. That's nice. And that stopped, and this is the one that's still running. All right, so we'll just let this chill and we'll come back. Okay, little update on this. So I ran into this random error. It just failed. And if you go to the logs, we don't know why it failed. It just says unknown error. Oh no, this is another one. This is deployed. This is the stopped one. This is one we want to look at. Oh, stopping app, unknown reasons. Okay, so it just failed. We don't know why. So what I did was I tried to just run it again. Sometimes that happens. And then I got this error, modal debug. Remember that code I put here? Apparently, I think Claude may have hallucinated, which means it just made it up. It had a similar like .debug code elsewhere that other code uses, so it assumed this was a real thing, but Modal has no attribute debug. So I just deleted it, and we can look at the logs on here. So then I reran it with the same code as before. Python Quen Modal, it's running, and then if you can command click, it will take you to the log. Generate text is inactive, so it's not running right now. Okay, so here's a super quick sped up version of my 15 minutes of debugging how to use Modal. It looks like deploy app is actually the new code, because remember they replaced stub with app. We can get rid of this. We saw that it printed, see, and this was very quick to run deploy stub after it had already been made, so I guess it doesn't make a new one. And then here it's running our prompt, so give a short introduction to large language models. Ooh, we can try it again. Let's do a different one. And we'll just run it one more time. And it'll go much faster. And again, you can view the deployment. I looked here and it just becomes idle. So it output that. Cool. So you get the idea, and you can just keep playing with this if you'd like. And I hope you enjoyed. So let me know in the comments what you think and how this went for you.